construct a model and then make a prediction. Okay, so the unit root is so important. Unit root can help us identify whether the time series is stationary or non-stationary. Okay. So what is a unit root test? You know, this is a AR1 model, right? In the AR1, if coefficient beta equal to 1, it's a random walk, okay? If coefficient beta equal to 1, it's a random walk. But how can we test whether beta equal to 1? There's no way to directly check. If you run this regression, there's no way to directly check whether beta equal to 1. So for both left-hand side and right-hand side of the equation, we minus yt minus 1. And finally, you get, by reparameterizing, you get this equation. We call this equation Dickey-Fuller test. This is a so-called Dickey-Fuller test. Okay? We can give this variable another variable named phi, right? This is so-called Dickey-Fuller test. In the Dickey-Fuller test, you can just test whether the coefficient phi is significant. If the phi is significant, it means beta minus 1 is significantly different from 0. As a consequence, in the AR1 model, beta significantly different from 1. This is a Dickey-Fuller test. However, I should say the Dickey-Fuller is only adequate if the residual is an ID process. In other words, white noise. There's no autocorrelation. If the residual, no autocorrelation, Dickey-Fuller adequate. But in some situations, residual have autocorrelation. How can we address it? We introduce ADF, okay? Augmented Dickey-Fuller test. We just add a lag term of dependent variable as a independent variable to control for this autocorrelation. Okay? We introduce the ADF. Okay? In the ADF, in fact, we should also test whether the coefficient phi is significant. If the coefficient phi is significant, it means beta minus 1 significantly different from 0. As a consequence, beta in the AR1 is significantly from 1, right? This is the ADF test. Okay? I'm going to show you how can we just how we will review how can we construct the ADF in the TCE. What I also want to emphasize here is that unit root can only help you to identify whether there exists unit root. But how many unit roots? We don't know. Okay? The ADF test only help you to identify whether it's stationary or non-stationary. But what's the order of integration? We don't know. Okay? So if your unit root test suggests an insignificant result, it means non-stationary. If the test is show the result of non-stationary, you should also test the first difference. Okay? If the first difference stationary, you can conclude this is an I1 process. If the first difference is still non-stationary, you should keep to test the second difference. If the second difference is stationary, you can conclude this is a I2 process. Okay, this is a process of the ADF test. So in the TCQ, the unit root test also use discrete statistics. You can formulate a model. In fact, we know most of the financial terms they are I1 process, so we add both initial time series as well as the first difference into the test. Okay, we test both. We use the unit root test. The unit root test, how about the length? We identify the length based on the frequency. Okay. If you use monthly data, so we use lag length should be 12. Okay, 12. Then here we get the result. In fact, you can use AIC, the lowest AIC, to identify the optimal specification. In this case, these two specifications have lowest AIC, right? These two specifications have lowest AIC. We can say these two specifications are optimal specification. However, regardless of which specification is optimal, in fact, all of the specifications suggest non-stationary. Okay, initial time series non-stationary. about the first difference. The first difference of time series shows significant result, okay? Significant result. It suggests stationary, okay? Initial time series non-stationary, first difference stationary. We can conclude this is an I1 process, okay? We can conclude I1.
How you see it? Why you say the first is not and the second is yes?
Because we get significant coefficient.
Oh, okay.
Here is significant. It means a phi significant. So it means reject not homologous. Okay? So we can conclude this is the I1 process. Initial time series insignificant, okay? The first difference significant suggests stationary, okay? We can conclude this is I1 process, okay? Some students have read the parent procedure, okay? And asked me how can we conduct the parent procedure. In fact, this parent procedure, a lot of steps ask for the joint test, okay? Ask for the joint test. However, if you use the ADF test by PCGIF, the test function does not appear. How can I do this? I should say, if you want to follow parent's procedure, you should construct the augmented decoupler test yourself, okay? How can we do this? Candidly, model for time series data, okay? Model class should be single equation dynamic modeling, okay? We just take the initial time series log level of the, this exchange rate as an example, okay? What should be the dependent variable in the ADF test? This should be delta YT, right? The first difference, okay? So you should add the first difference as a dependent variable. What's the independent? In the independent, we also add a lag term of this dependent, right? For example, if you want to add 12 lags, so here you input 12, and you have add a dependent variable, constant, and 12 lag term of dependent. What is the key independent? What is the key independent? YT minus 1, okay? YT minus 1, so with a lag length 1, right? YT minus 1. In some situation, you also want to add a trend. How can I add a trend in the regression? Just select trend and add it, okay? Here, we have construct the augmented decoupler model with constant and trend, okay? With constant and trend. And finally, we get a result, okay? This is also the ADF test, okay? With 12 lag terms, okay? The key independent variable is a YT minus 1, YT minus 1 also. Also, we include the constant trend, okay? For example, in the second step of the parent procedure, I ask you to test the joint test of the maybe these two coefficients. How can you conduct the joint test? Just use the text function here. After you construct model, text function appear. Use text function. Exclusion restriction, okay? Exclusion restriction. If you want to test whether this coefficient jointly equal to 0, select the 2. Okay? Here you get a result. You can test whether these two are jointly equal to 0. Now, hypothesis of F test is these two variables jointly equal to 0. If the result is significant, it means these two coefficients are not jointly equal to 0. Okay? This is how can we construct the ADF but following the parent procedure. You know, by following the parent procedure, you should construct the model step by step, okay? When you check the something assignment, you find the second question only accounts for 10% of the overall score, right? It only accounts for 10% of overall score. And also, in lecture, our professor never talked about the parent procedure. I only talk about the parent procedure in seminar as well as computer lab.
Sorry, what procedure?
Parents procedure.
Parents.
Yeah, parents procedure. Check your seminar 2, I think. Our seminar 2 talk about it. Okay. I also upload 2 documents. If you can follow the parent procedure, it will be okay. In fact, by following the parent procedure, you will get more accurate results. But you know, our lecture never mentioned it. So if you just take the ADF by PCGIF automatically, it's all right. Okay? You make the decision, okay? You know this question only accounts for 10% of overall score. So also you have several variables if you think follow parent procedure is too complex, you can just use the ADF. Okay, this is you make your own decision. Okay, but actually the emphasize here is more accurate way is follow parent procedure, right? But if you only follow ADF, all right, okay. In fact, parent procedure is also the ADF-based step, right? This is the second question. Okay, this is the second question. Next question asks you to construct ARMA model, right? ARMA model. How can we construct ARMA model? We follow the Fox-Jenkins methodology. We follow Fox-Jenkins methodology, right? For the Fox-Jenkins methodology, we have 3 steps. How can you construct an ARMA PPO model? We follow Fox-Jenkins methodology. The first step, identification. First step, identification, okay? Identify the order of ARMA, okay? Identify the order PQ of the ARMA, okay? How can we identify the order of ARMA? We use ACF, PCF, okay? We use ACF, PCF. The second step, estimation, right? Estimation. In other words, estimate the parameter, the coefficient of the ARMA, right? We are going to estimate the beta, coefficient beta, okay? How can we estimate the result? We use maximum likelihood. Okay? Alternatively, we can use least square, okay? For example, ordinary least square. But in PCK, we tend to use maximum likelihood, okay? Pay attention, we use maximum likelihood. The third step is also quite important. Model checking, right? Model checking. Diagnostic checking, okay? Model checking, okay? How can we check whether the model is adequate? Two-way, okay? Two-way, overfitting. And the residual-based test, okay? Young-Box test. In other words, Q statistics. Q statistics. Okay? Some students ask question about overfitting, okay? How can we overfit the model? For example, if your ACF and PACF suggest AR1, okay? If your model, your ACF and PACF suggest AR1, you should overfit. You should try to overfit AR2, right? You should try to overfit AR2. But which one is preferred? I want to ask a question. After the overfitting, which one is better? Why? It's parsimonious, right? But I should say, in this case, AR1 is only adequate if this coefficient is insignificant. Okay? Initially, your plot suggests AR1. You try to overfit AR2. In AR2, if the coefficient of YT minus 2 is insignificant, your AR1 is adequate. If the coefficient of YT minus 2 is significant, the AR1 is not adequate, okay? You should use AR2, okay? But, for example, if you overfit two models, one is AR2, one is MA5, which one is better? AR2 is better because it's more parsimonious, right? But for the overfitting, for the AR1, for example, the beta coefficient beta is significant. In the AR2, the beta 1 for the YT minus 1 is also significant. You should check whether the coefficient of AR2 component, YT minus 2, is significant. If it is insignificant, the AR1 model is adequate. If it is significant, you should use AR2, right? This is a principle of overfitting, okay? And for every model, you should use Q statistics to check the both of the model. They are adequate if the error term is subject to ID process. In other words, no autocorrelation between error terms. Okay, so you should also conduct a Q statistic to check whether the residual is subject to IID. Okay, I'll show you how can we do this. So the first step, identification, you should plot for the log as well as the first difference. Okay, we use time series properties, create separate plots because we add two variables. One is the initial time series, the log level of the initial time series. One is the first difference of the log level. Okay. In fact, according to the ADF test, we have no. The initial time series is non-stationary. Okay. In fact, this ACF and PCF also suggest non-stationary effect. Why? Because the ACF does not decline. Okay. Until the 20th lag, the ACF there is also very strong spec. Okay. Also very significant spec. Okay. And also, if you think it looks like AR1, I should say the coefficient is 1. Okay, the coefficient here is 1. It also suggests random walk. Okay, so from the first plot, we know the initial time series non-stationary. How about the second plot? In fact, we construct the ARM model based on the first difference. In other words, according to this plot. Do you think this plot show any particular pattern of ARM? In fact, it's not very clear, but we know the first ACF and PACF significant, the second leg insignificant, the third significant, the fourth significant, the fifth insignificant. If it shows very clear pattern, you can just based on the ACF and the PACF to identify the order of ARM. Okay, but in this case, we know there is no very clear pattern. However, there is some significant result of ACF and PACF. So I suggest you can try from AR1, okay? You can try from AR1 and overfit the model, okay? But I know until the fourth leg there is a significant result. I just show you an example of construct model of AR4, okay? I show you an example of AR4. The category model for time series, model plus, a final model, okay? Add a stationary process in the model construction, okay? Add a first difference as a dependent variable, okay? If you want to estimate the AR4, the AR order should be 4, okay? The M order 0. And this is also important. You should fix parameter D at 0, okay? This is the integration part, okay? Because we add a stationary process, so you should fix the integration parameter D at 0, okay? In other words, you include the integration. This step is also important because we need to use maximum likelihood to estimate the result, okay? We use a maximum likelihood. And finally, you get the result. This is the AR4 model, okay? This is AR4 model. When you check the model, the AR1 component significant, okay? The AR3 component significant. The AR4 component significant, okay? The p-value significant. But how about the AR2 component? The AR2 component is insignificant, okay? It is not significant at the 10% level, okay? It is more than 10%, so it's insignificant. The constant is also insignificant, okay? In other words, you want to test whether we can exclude these two parameters from our model. How can we do this? Also conduct wall test, okay? Wall test. You can check your note of computer lab 3. It shows the wall test, okay? Wall test just use an exclusion restriction function, okay? You want to test whether there are two components as well as a constant jointly equal to 0, okay? So we select these two. Okay? Our result is insignificant. What is that result is a wall test. It's jointly equal to 0. It can't reject jointly equal to 0. It means they are equal, jointly equal to 0, so we can exclude them. But how can we construct ARM model but include some insignificant AR or MA component? In fact, just repeat the process. If you want to remove the constant, just remove it, okay? Remove the constant. But how about the AR component? In our case, we want to include the AR2 component. So you should fix AR lags here, input 2. Okay? When you include 2, it will exclude the AR2 component, right? Take note, okay? Because the node of our computer lab does not show this step, okay? Fix AR lags as 2, it will exclude the AR2 component. Finally, we get the result. This is a AR4 model, but without AR2 component and constant. This is the AR4 model without AR2 component and constant. Okay. This is how can we construct the ARMA model. Okay. This is how can we construct the ARMA model. Next question. If that is in fact, the ARMA model is a fourth question, I think. The third question, before this ARMA model, there is a question about PVP, okay? PVP. In fact, PVP test are not related to the ARMA as well as the track modeling. This is a particular kind of the test, okay? In fact, it's an application of the Johansson test, okay? It's an application of the Johansson test. What is a PVP hypothesis? Spot exchange rate equal to domestic price divided by foreign price, okay? Spot exchange rate equal to domestic price divided by foreign price, okay? I use P and P star to denote domestic price and foreign price respectively, okay? How can you test this function? How can you test it?